Hey everybody, glycogen is kind of a tricky unit, so I wanted to make another video on it. And going through the slides, that's complimentary for the other video I've already made. Make sure to watch that one first. It's going to explain the pathways and the regulation a whole lot better. I'm just going to kind of show you how I went through my notes on what to highlight, and hopefully that'll kind of connect the dots from what I was writing down on my other video versus what you have in front of you with your notes. At the end of this, I'm going to go through some test questions, so make sure you stick around to the end, or you can skip there now if you want, but I'd recommend looking through this to connect the dots and make the associations and really get the pathways in really well. So talking about glycogen, most of that stuff is going to be on this unit here, or this slide here. And this I'll review from Biochemistry 1. A lot about the structure here, lots of overview stuff. Things like this kind of confuse the crap out of me, so I didn't find it too useful. Now this is all overview stuff. It's going to be into more detail a little bit later when he starts to write it out. So this is what helps me the most. You know, the last couple slides you saw glycogen, phosphorylase, taking this is glycogen, glucose N, then you phosphorylate it, and one of the glucoses pop off, so you have a glycogen chain that's one glucose less than before, and you have one glucose with a phosphate on the first carbon. So that's for 90% of them. And then the debranching enzyme, note it has the hydrolase activity to knock off the glucose, and you just get a free glucose right there. And it also has the transferase activity. So when you debranch it, you can transfer whatever you just broke off from the branch to the end of the molecule. I illustrate that in the other video as well. But yeah, on this one, this bifunctional enzyme is really the key debranching enzyme. His other favorites are these two here, phosphoglucomutase. It's involved in both the degradation and the synthesis pathways, and glucose 6-phosphatase, which is the one that's membrane bound to the ER, a liver-only enzyme. So make sure you know that really well too. He'll ask a question one way or another. Just know all of these reactions. I wrote them all out on one page in the other video. If having it across all of these different slides is a little too much to keep track of. So things are a little bit different in the muscle. Make sure you know the difference. So showing the G6-phosphatase on the ER membrane here. This might be the only place it is. Make sure you just know GLUT2 is liver and GLUT4 is muscle. He likes to drive a few points home in this unit, and that's a big one of them. GLUT2 is a liver glucose transporter. GLUT4 is muscle. Heart is a muscle, so anytime you see heart, you can just write muscle right above it. It's going to be the same thing. That's what he's asking about. So the ATP yield is good to know. Not too many questions about it, more of a secondary priority sort of thing, but if you understand how the degradation works, it makes sense. So synthesis pathway, make sure you know this really well. We're going to see this UDP glucose come up on a test question, so make sure you recognize it here. And this is just to make glycogen, but remember you're also branching, so you're going to see branching enzyme. Branching enzyme also uses UDP glucose. So it's branching. Glycogen synthase is making it the linear pathway. Branching enzyme just adds this little branch right here. So they're both important in the synthesis. Debranching is only used in degradation. Glycogen comes up. It's not a regulated part of glycogen. Tyrosine is something he could ask about. In the test, we're going to see he asks about covalent bonding, which is what he's showing right here. I could see that maybe being a quiz thing, or that happens 6 more times, being quiz level material, but I haven't seen it on the latest tests. So any chart for regulation, definitely have this memorized. We're going to go into more detail about these forms in the other video and later in this unit. This is good stuff. If this doesn't make sense to you, it's all going to be either in chart or text form. So if this is confusing you, don't get too caught up in it. Come back to this once you've seen, a slide like this. Make sure to know this really well. Make sure to know the difference between muscle and liver phosphorylase. Glucose sensor is a big thing here. Know your inhibitors and activators, of course. So energy charge is going to be high energy charge inhibits, low energy charge activates. And that makes sense because phosphorylase is the one that's doing the degrading. So if you have energy, you don't need to use your energy stores. You don't need to activate phosphorylase, which is going to degrade when you already have, the end product that you would be going for. But if you have low energy, then you're going to activate the degradation to get more energy. So I talk about this in the other video. The main thing to know about phosphorylase kinase comes up in a couple questions. It's both phosphorylation and calcium. Calcium mainly in the muscle. Liver doesn't really care about calcium. So pKa is the activator. This is another point that he's going to test you on, and definitely know that glucagon is only going to work on the liver. Epinephrine, liver, and muscle. That's another one of the key points that's on every single test. This is the illustration of the last slide showing turned on by phosphorylation and calcium. So it's regulated very similar to glycolysis, your basic glucagon and epinephrine versus insulin. As an illustration, if it helps you, great. If not, don't stress too much about it. It's good to review this Unit 2 stuff where you have the hormone binding that results in pKa. pKa is going to turn on phosphorylase kinase, and phosphorylase kinase is going to activate phosphorylase. Remember, phosphorylase is going to degrade. Degrade the glycogen. So what we've seen before is, usually have pKa directly working on, the thing that's going to degrade. This is just one extra enzymatic step here that has another regulatory thing with the calcium and everything, if it's in the muscle. So there's just one extra middleman here, and that's the phosphorylase kinase. So make sure you review that slide. We'll look at some questions that, when you're lysis, when you're degrading, glycogenolysis, it's going to be caused by epinephrine, liver, glucagon only. So you see that same point coming up in a couple different slides. Know this slide really well. I mentioned this in the video that he talks about insulin-sensitive kinase here, but I haven't really seen that come up in the test question, so I wouldn't worry too much about that. Maybe a quiz level sort of stuff. know the big picture about synthase is for glycogen synthesis, and it is active when it's dephosphorylated. And when are you going to synthesize glycogen? When are you going to have energy stores? When you have extra sugar, when you have extra insulin. Just a good review slide to know. I talk about this using the regulation in the video, so a lot of this stuff gets pretty complex, and this kind of starts to confuse me a lot, so I wouldn't worry too much about it. Synthase kinase is also discussed in the other video for when you're making glycogen to store in the liver. I think that's about it. Everything else this is all just illustrations of what he's talked about in text earlier in the unit. So I think we should go look at some test questions now. This is the fall 2013 test. Which of these reactions always takes place in the liver? I think always takes place in the liver, he's meaning only takes place in the liver. So if you look at A, C, D, and E, they take place in both liver and muscle. But the liver is the only thing that's actually going to make glucose. It has that G6 phosphatase. It's going to make glucose. So make sure you know which enzymes we're talking about here. So here's the slide reference, slide 19. This is debranching enzyme, G6 phosphatase, UDP glucose pyrophosphorylase, I think is the enzyme, the one that has UDP glucose pyro in it. This one's phosphoglucomutase, and this one would be glycogen synthase. Here, whenever you see the +1, think synthase. On slide 30, glycogenin is the only one that's going to bind covalently to glycogen. The other ones are more enzymes, so not doing much binding. That's a strange wording of the question. But glycogenin is your primer for glycogen, so that's the only binding. I'm not sure. It does bind covalently. I'm not sure if that's a necessary word. Protein is turned on by phosphorylation. So I think you can find that on slide 39. Glycogen phosphorylase would also be turned on by phosphorylation, because this enzyme here is going to phosphorylate glycogen phosphorylase. This one is going to be turned off by phosphorylation. pKa is the one that is doing the phosphorylation here. The one that's adding it. PP1 would do the opposite. Glycogenin has nothing to do with it. This molecule does not appear to stimulate glycogenolysis in the heart. Just remember, anytime you see heart, just write muscle there. And glucagon is our liver-only molecule. In the heart, you're going to be stimulating the lysis. You're going to be stimulating the degradation by epinephrine. And epinephrine has, cyclic AMP and AMP in the pathway, and it's going to be done by glycogen phosphorylase, which is partially activated by calcium. So straight up, just knowing the reaction, glycogen synthase. Here's glycogen +1, so that's going to be your synthase. You can go through and, some of these are just regular plain old glycolysis reactions, and some of them are other parts of the degradation process, or the G6 phosphatase releasing glucose. Which of these is not correct for a fasting liver? Glycolysis, remember glycolysis happens in the fed state. That's unit 3, fed state, insulin. Fasting liver, you are going to start getting rid of your glycogen stores because you have epinephrine and glucagon causing pKa. You will have insulin down because this is up. And glycogen phosphorylase is the one that's doing the degradation. I'm sorry, on the last one I had a slide for you. It's 26. I think that was all of the glycogen synthesis reactions. Make sure to know those really well again. See which protein is used not used to make a glycogen particle in the heart from blood glucose. So this is talking about glycogen synthesis. So synthase will be used. Phosphoglucomutase is both. I'm just going to keep telling you that so no one has an excuse to miss it. Branching enzyme is not on that slide 26. It's on a couple slides later, so make sure you remember branching is part of the synthesis. GLUT2 is our answer here because that is liver only. So you could add GLUT4. GLUT4 would be a correct answer on here. So that's in muscle/heart. And hexokinase, because when you're doing glycogen synthesis, you have to go through that first step of glycolysis, which is done by hexokinase. So remember, glucokinase is liver only, if he tries to throw that one at you from Unit 3. Alright, asks it here. We've talked about this 10 times already. The enzyme used in both. Make sure you know where all these other enzymes are. Remember, glycogen would be synthesis only. Which metabolite is essential for glycogen degradation in liver and muscle? So I mentioned this when I was going through the slides. The degradation, what he's talking about here is the debranching enzyme. If you look at the debranching, it's the bifunctional one, and one of its activities is hydrolase. So you need water to get rid of glycogen. So when people talk about losing water weight, they're burning up their glycogen stores, and they're using all of this water and getting rid of it. So that's why, like a low-carb diet, you lose a lot of water weight because of this debranching enzyme. All that water stores, you're burning up all your glycogen. Just kind of a side note, if it helps you apply it at all. If I confused you, just forget what I just said. Let's see, it appears to stimulate liver glycogenesis, so the synthesis. If you have glucose, you're going to either use it or store it. So look on slide 37 for that part of the regulation. I forgot again, debranching enzyme. It's on slide 18. Which enzyme does not appear to be regulated? So if you're looking at these two are the ones that are reciprocally regulated. They're the two main players. When one is on, the other is off. You can see that information on the regulation slide 33. Phosphorylase kinase is the one that turns that on, and pKa is the one that turns that on. So make sure you know all the connections there. Nothing is ever talked about with glycogen in regulation. So you can know it because of that or just by default. So if you look on 39 and 40, it talks all about phosphorylase kinase. Calcium in muscle. Remember, liver doesn't care about calcium. So which of these metabolites does not appear to regulate glycogen metabolism? I think you can find all of these on slide 37. Nothing is mentioned about glucose 1-phosphate. This is your high and low energy charge, low and high energy charge. You have phosphorylase is a glucose sensor in the liver. and G6-phosphate has a regulation role as well. You can find it on that slide. Last glycogen question. This molecule is a substrate for 2 glycogen enzymes. That's UDP glucose. That's a tricky question. If you look on slides 28 and 29, you'll see that glycogen synthase and branching enzyme both use UDP glucose in glycogen synthesis. Alright, I hope this helps. Good luck on your quiz and test, and I will see you guys next time. Have a good day.